Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. This is Dr. Ahmad Al Faris. Today we're going to answer Edexcel person, Unit 3, okay, May 2020, okay. As usual, we know that we have only a few questions about practical, alternative to practical, how we can use the information of inside the lab to make the experiment more accurate and get results of doing the experiment. First question, what do we have here? A student investigated the effect of what? The effect of temperature on the viscosity of oil, okay, by measuring how fast the oil flows through what? Through a funnel. He used the apparatus as shown. This is the measuring cylinder of oil. Okay, we have empty measuring cylinder, we have a funnel, and we pour the oil inside the funnel and go like this, okay? Pass through here. AI. State the piece of apparatus the student would use to vary the temperature of the oil. If I want to vary the temperature of the oil, that means what? I need to make it colder or make it hotter. Yes, we can use ice bath. Thank you, Hamza. We can use a hot or cold water bath and we put the measuring cylinder inside it, or we can put it on a hot plate directly. Okay, so heat the cylinder on a hot plate or hot or water bath, no problem. Okay. Yes, Bunsen burner cannot be useful because the same cylinder maybe melt or start to burn. Okay, and I want to make the temperature of the whole oil approximately homogeneous and have the same temperature. Okay. Okay, this is part A of the question. AI. Part B. State the piece of apparatus that the student could use to measure the time taken for the oil to flow through the funnel. I can use what? A stopwatch, right? Thank you, a stopwatch. Now the stopwatch can be used to measure what? To measure the temperature, or I can use a light gauge with data logger, but this will be to be more accurate. Maybe later they will ask a question about that. So let's see this, okay? Part B. At the 2 voltmeters, okay, sorry, the 2 thermometers, okay, shown being available. Okay, we have an analog thermometer and a digital thermometer. Okay, liquid and glass thermometer and digital thermometer. He chooses to use the digital thermometer. Okay, he chooses to use the thermometer. Justify his choice. Why he used the thermometer that is digital? Why? Why do you think digital is better than the liquid and glass thermometer, which is analog, and you can see that the scale is not that big? Okay, maybe, tamam. Exactly, because it has higher resolution. The smallest precision that can be read here, it's 0.1 degrees Celsius. That means it will be having what less percentage uncertainty. Okay, tamam. So we can write no parallax error, and higher resolution. So the percentage uncertainty will be lower. The percentage uncertainty will be lower. Good. Okay, that's good. Next. CI. Identify one control variables in this investigation. You can say that the mass or the weight of what? Of the oil. Let's say the mass of the oil, okay, or the volume of the oil. So the mass of the oil. And you can say the volume, since we are using measuring cylinder, the mass of the oil, or you can say the volume, okay? So that means, okay, describe how this variable can be controlled, how we can control it. We can keep measure the mass, okay, by doing the experiment, or we can we can keep measuring the volume by the measuring cylinder. So keep checking its mass using the balance scale, or we can say, okay, or we can say keep checking its volume by the measuring cylinder. If the volume will change due to the heat, yes, a little bit, okay. It's not. That's why I need to control it. That means that as the temperature increases, the volume increases. So I need to keep the same volume because I'm doing to find the rate of volume every second. How much the volume? Yes, by measuring the balance scale, by the measuring cylinder, by the measuring cylinder. Okay. You can take a screenshot from while to while, or you can write down the answer. Okay, take a screenshot if you please, or you can write down the answers. Okay. In part B, what do we have? A student initially measured the time from the starting to pour the water into the funnel to the last drop of the oil funnel from oil falling from the funnel. Okay, what they ask here: state how the rate of flow of the oil should be calculated. Now we know that the rate of the volume, it will be okay equal what? Rate of flow. What's the formula? Yes, tell me on the chat. Rate of flow. What's the formula? Exactly, it's equal volume of oil divided by time. Time of falling. Excellent. Good. Next, what do we have? Double I. Describe how the same apparatus could be used to calculate more accurate value of the rate of flow of the oil. Now the rate of flow of the oil, I told you before, we can use a data logger and taking the time, okay, or for that connected to the timer, or we can take a video, okay, and make uh, uh, record the video, okay, for how the rate of flow pass, okay, and we will be more accurate. Or we can start the time from where we pour the same instant way that we put the water and the oil inside the funnel, okay, and we can start measuring, okay, also the time when it's the funnel is empty. So it depends on the point of view. What do you need to measure? Okay, since we are trying to measure the rate of flow of the oil here, so we have to be more classified and more clear, okay, to do this. If we look to the mark scheme, what do we have here in the mark scheme? In the mark scheme, they say that here, look, start the timer of oil has been poured, or stop the timer before the funnel is empty, okay, because I don't need the last drop here. Okay, record the volume after a fixed period of time, okay, or repeat the same temperature and calculate the mean time, okay. So we have to find the average. Use a data a light gate, okay, and electronic timer to avoid human error or reaction time. All these are accepted answer. We need only two of them. So what I can say here, I can say that by using a data logger, data logger connected to electrical timer and measure the time, the starting time, as the oil is poured, okay, into the funnel until the time before the funnel is empty. The funnel is empty. Repeat this. Repeat at each time, at each temperature, sorry, at each temperature, and find the average. Okay? Good. Yes. Any question? Is it clear? Take a screenshot if you please. Okay, and let's move on. Question number 2, what do we have? A student investigates how intensity of light emitted by a light emitter diode LED varies with the potential difference PD applies across LED. She measured the intensity of light using the light meter, okay, which has shielded from the external light source. She plot her results on the graph as shown, okay, at different power potential difference, how much was the light intensity, and this was the graph. Add a line of the best fit on the graph. Now you can draw this with a pencil first, try to make it very thin line and very smooth, then you can redraw it with a pen, okay? So it will, you know that the LED starts from 0 and goes like this to the 0, okay? Then suddenly it goes up and try to pass through these, most of the points as smooth as possible, and do not go back as I did here because it's hard to draw it by this pen at the computer, okay? This smooth line, you get 1 mark to draw it, okay? Any question? Try to make it smooth, don't do like what I did, okay? If I have a pencil, I will draw it as smooth as possible, okay? Good. Any question? Next, given that the value of the potential difference at which the LEDs start to conduct. Now, I didn't start to conduct it from 1.5. I move a little bit, okay, in my graph forward, so it will be approximately 1.6, 1.7, okay? So it will be from the minimum graph from what I draw. So for example, what I draw here, it was what? 1.7, okay, volt. Good. Double I. Calculate what? Calculate the minimum energy that must be transferred by an electron in the LED, okay, for the light to be emitted. Now, I know that the work here is equal to what? To the voltage multiplied by the charge, okay? According to the definition of the potential difference is work or energy needed for each charge that they ask about the minimum energy. So the energy, what's the value that I have here? It's 1.7, the voltage that I get it, multiplied by the charge for each one electron, which is 1.6 times 10 to the power of negative 19. And my answer will be approximately, who has a calculator? It will be 2.4 maybe, okay, or 2.72, thank you, 2.72. Okay, times 10 to the power of negative 19, and I'll write it as two significant figures. It will be 2.7 times 10 to the power of negative 19 joules. Is it okay so far? Any question? Okay, this is the minimum amount of energy, okay, that must be transferred by the electron by the LED. C. Light is emitted when the electrons released energy as a photon, okay? The student tested a second LED, not the same one, okay, which emits a light of wavelength 625 nanometers. That means we have to multiply it by 10 to the power of -9, as we know, to convert it into meters, as we did today in the exam. From her results, she determined the minimum electron energy. It will be how much? 3.1 times 10 to the power of -19 joules. Okay? Calculate the value of the Planck constant from these data. Now we know that, okay, energy for each photon, what's the formula for it? It's exactly HF. And we know that speed of light equals frequency multiplied by the wavelength. That means the energy for each photon, it's equal Planck constant multiplied by the speed of light divided by the wavelength. So I make E as a H as the subject of the formula. So it will be the energy multiplied by the wavelength divided by what? Speed of light. And I will substitute the values. The energy, which is 3.1 times 10 to the power of -19, multiplied by the wavelength, which is 625 times 10 to the power of -9, divided by what? Divided by the speed of light, which is 3 times 10 to the power of 8. And by using calculator, Planck constant, it will be 6.5 or 6.46, which is 6.5 times 10 to the power of -34, okay? Times 10 to the power of -34. And what's the unit here? It's a joule per what? Joule per second. Joule dot second, sorry. Joule dot second, yes. Good. Is it clear? Okay. Next, what do they ask here? The LED does not produce monochromatic light. Does not produce monochromatic light. Explain how this would affect the value of the Planck constant calculated. Now, we know that if the LED does not emit a monochromatic light, that means this wavelength, it will not be the same value. Okay? Tamam? Okay, one of the questions, why joule per second? Well, look here, I will tell you why, okay? Now, the energy in joules, okay, Planck constant multiplied by frequency, which is per second. Over per second, okay? Per second will move upwards, so it will be joule dot second, okay? Did I answer your question, Ahmad? Okay, you are welcome. Okay, now, again, they said that the light does not produce a monochromatic light, okay? The LED. Explain how this will affect the value of the Planck constant that we calculated, okay? That means we have a problem with the wavelength or with the frequency. There is range of the answers, okay, of the wavelength here. So that range, it gave me uncertainty of calculating this value, okay? So whenever the wavelength is longer, that means the frequency, it will be less. That means the Planck constant will be higher to get to the same energy. That means the uncertainty of the Planck constant that we calculated has what? A range of possible value. That we don't have what? A certain value, okay? Good. So if I want to write down this, I'll write it in this way. This causes what? Range of the frequency due to the uncertainty of what? Of the wavelength. So there will be range. There will be range of values of Planck constant. And has uncertainty. For example, if the wavelength is longer, the frequency will be lower. So for the same energy, Planck constant will be lower. Okay. Thank you, Hamza, for your answer. Yes, your answer is similar to my answer. I will read it for you. The range of wavelength will be decreased. So this means that the value will have more percentage uncertainty. No, actually, the range of the wavelength will be increased. That means I will get what? More uncertainty, not lower uncertainty. Okay, the percentage of uncertainty will be higher. Yes. Okay. Okay. I understand you, Hamza. No problem. In part C, what do we have here? In part E, sorry. The accuracy, okay, of the value of the Planck constant calculated depends on what? The minimum potential difference determined from the graph. Explain how a student could reduce the uncertainty in her value of what? The minimum potential difference. Now look here. The minimum potential difference that it's work, it depends on my graph, okay, and my plotting, and my drawing. So I'm not accurate. So what I will do, I will take several readings, okay, here to get the exact value where the minimum voltage that is thought to work, okay, when the voltage, okay, it's enough to make the lights come out from the LED. So that means I will take several measurements between these values, between 1.5 and 2 volt, okay, and it will be more accurate, the best fit line that I will draw it. And this question, they ask similar question, okay, I think in the year 2014, okay. So what I'm going to say, by taking several values, several readings of the intensity in the range of 1.5 V to 2 volt potential difference, 2.0 potential difference, to make sure, to make an accurate what? Drawing to get the potential difference, where it started. Okay. Yes, thank you. Thank you, Hamza. Yes. Another answer, another suggested answer. Is it clear? You can take a screenshot if you want. Next, question number 3. What do we have here? You can see that we only have few questions, and most of the students, they finish the whole exam in approximately an hour or 1 hour and 5 minutes, something like this. Question number 3. A student investigated how the power output of the solar cell, okay, is affected by what? By the temperature. The intensity of light incident on the solar cell remains what? Constant. Okay, so the light intensity remains constant. We change the temperature of the what? Solar cell to investigate what's the power, what happened to the power, is it affected by the temperature or not? Okay, he uses a square he used a square solar cell. Alhamdulillah. Okay, the student determined the power output of the solar cell, okay, at different what? Temperatures. Complete the diagram to show a circuit that would allow him to determine the power output of the solar cell. What he did here, He drew the solar cell. He drew a resistor. What do we need here to know what is the power? I need to what? To measure the voltage, and I need to measure what? The current. So that means I'll put an ammeter in the circuit. What shall I put also here? Now I need to connect the voltmeter, okay, across what? The solar cell only, because I'm going to study what? The power output of the solar cell, okay? Now, what else do I need here to connect? So I will connect nothing else, okay, in this circuit. That's it. If they ask us to change the voltage or to change the current, I will what? Put a variable resistor in the circuit here. But they didn't mention anything about this, okay? Now, good. Any other questions? Is it clear? Okay. This is part A of question 3. Part B. Describe how the student could ensure that the intensity of light incident on the solar cell remains constant. How can I make sure that it remains constant? Now the solar cell is supposed to have same distance, okay, and same angle and perpendicular, for example, okay, and I have to what? To cover everything, as they tell us. Okay, maybe I put a black background light, so it will control how much the background radiation from the surrounding in the room, so there is nothing turned on, okay, or there is no light reflected from any other surfaces, okay. So all these are accepted answers here. So I will write that, make sure that the lamp is perpendicular to the solar cell and still at the same distance, and keep it at the same distance far from it. Okay. Mister, can you show part A again? Yes, take a screenshot. This part A only. We need a voltmeter and a meter. They didn't ask us to change or anything else. Okay. We need a voltmeter and a meter to measure the potential difference and the current that passed through the solar cell. You are welcome. Okay, take a screenshot for the part B. You are welcome. In part C, what do they ask? State a method the student could use to increase the temperature of the solar cell. How can I increase the temperature of the solar cell? We said in the previous question number 1, that we can put it inside water bath, okay, hot water bath, or we can what? Directly aim it to what? A hair dryer, okay. So the hair dryer with hot air, okay, it can increase its what? Its temperature, and we can use a thermometer to measure its temperature. That's something else. So put it inside what? Hot water bath. Okay, hot water bath. Okay, next. Why perpendicular in part B? Okay, now you can say that I keep the angle, okay, same angle. So the light intensity is perpendicular, or with the same angle, it remains the same. So the light intensity doesn't change, because we know that the light intensity has two components. One is vertical and one is horizontal. So the one which is vertical, it makes how the intensity that be absorbed by what? By the solar cell. Okay. So if I put it perpendicular and keep the distance the same distance, my experiment is accurate, and I try to make the control value, which is the light intensity, remains the same. Did I answer your question? Okay, you are welcome. In part D, what do we have? At room temperature, the student measured the potential difference, this is V, okay, and the current 45 milliampere, that means I need to multiply it by 10 to the power of -3 to make it in ampere. Calculate the power, okay? Now we know that power equal IV, so which is 45 times 10 to the power of -3 multiplied by 2.74, and by using the calculator, as you can see here, we have two significant figures, here we have three significant figures, so the answer can be two or three significant figures, so it will be 0.12 watt. Yes, it will be 0.0123. Yes. Okay, so here it will be more accurate. Okay. Yes. Next, he measured what? He measured the intensity of the light incident in the solar system. Okay, the solar cell, sorry, the solar cell to be 200 watt per meter squared. Okay, so this is the light intensity. Calculate the efficiency of the solar cell at this room temperature. They ask us to find what? The efficiency. Now we know that the light intensity gives us the power incident on the surface area. Light intensity equal the power N, okay, over what? Over the area. This power, that is the power out, how much the current come out, okay? So by doing cross multiplication, I will find the power N, okay, which is light intensity multiplied by area, which is 200 times the area, and with these areas, we have to divide them by 1,000 to convert them from being millimeter to being what? Meter. So it will be 60 over 1,000 square, because the length is as this, it's square length as width, okay? And we will find how much is what is the power output, and it will be 0.72 watt. This is the first step. The second step, okay, I will find what? The efficiency. And the efficiency, it's equal the power out, okay, divided by the power N multiplied by what? 100%. So the power out, which 0.12, divided by the power N, which is 0.72, multiplied by 100%, and the answer will be how much? It will be 17%. Okay, take screenshot if you please. Okay, let's move on. Can I say 17 divided by 100? It's a ratio. You can write it like this or like this. You can write it 0.17 or you can write it 17%. It's efficiency. Efficiency is a ratio, yes. Okay. Next, part F. What do they ask here? The student make measurements of the potential difference V and current I for the solar cell over range of what temperatures. His results are recorded in the table. Criticize these values. Every time since 2009 until now, they keep repeating the same question. Criticize the values. And the values of the mark scheme, they will be the same if you would compare the answers. For example, number one, we have only what? Few readings. Only we have 4 readings. Okay, this is not enough to do an experiment. At least we need 8 or 10. It depends on the experiment. Number two, there is no evidence for repetition. Okay, there is no evidence for repeating the voltage with the current and find the average current. Also, okay, look here to the values here. Okay, there is a small range of change in temperature from 15 to what? To 50. 15 to 50. Maybe you can do it until 70. Okay, and you can see that. Okay, here the values, they don't have the same consistency. Okay, they are here 3 significant figure, 2 significant figure, etc. Okay, so inconsistent what? Current. Okay, for what? For the readings here. Okay, and the same thing here. Okay, the temperature here, we can say that it's 20, not a 21, not 20.5. So we are not sure. Maybe this is one significant figure. So all these are what? Are what things that he did, this student did a mistake, okay? So I'm going to write, yes, thank you, Hamza, for your answers. Only 4 readings, which is too few. That's one answer. Another answer, okay, I can write here, okay, too small range of temperature. Also, I can say here, okay, inconsistent interval for what temperature readings or inconsistent current values. Inconsistent potential decimal places in current values. One of the questions, Mr. When should I set inconsistent numbers and inconsistent significant figures? Inconsistent significant figures or decimal places, always. Okay. And when we set consistent of decimal places. Now, okay, now look here, it depends on the value. Now we can see that here there is decimal places and here there is no decimal places. So the idea it's the same, okay? That we don't have the same number of significant figures, okay? So you can write it in both ways, but it's your decision to write decimal places, okay? Can we say consistent number or significant figures? Yes, you can say it both ways, okay? Another answer, what do you mean by too much a small range in temperature, Mister? Now, the temperature here, it's only from 50 to 15, okay? The temperature, okay, can reach 70 or 80 or 100, okay, below the sun, okay? Not in the shade. So that's why the temperature here is few, okay? You can, now we need only 2 criticize things here about the readings. So make sure that you write the most common sense that you can have the marks from it, okay? Good? Okay, and they keep repeating the same ideas here. Okay? Okay, double I. What do they ask here in double I? Over the range of temperature shown, the relationship between the power output of the solar cell and its temperature is what? Is linear. Describe how the student could use a graphical method to determine the change of the power output for each 1 degree Celsius of the temperature increase. Now we can do that by what? What do we need? Look here. What do we have? We have voltage and we have current. We can multiply the voltage with the current to find the power for each temperature, right? So we can plot then a graph between what and what? Between power, okay, in the y-axis with what? With the temperature in x-axis. Then we can what? Find the gradient, if it's linear or not. One of the answers, okay, from Hamza, okay, taking readings of the power, okay, calculating the power, not taking the readings of the power because I don't know the power, okay? I don't have it in the readings, okay? Okay, then put on the range of plotting the graph between power versus temperature and draw a straight line. Then what? Okay, find the gradients, okay? Okay, good answer, Hamza. Okay, so I will do that in several steps. First, calculate the power for each temperature. Then plot a graph of power versus temperature and draw the best fit line. Then calculate the gradient of the line. Because the gradient here is the temperature, okay, for each power for each degree Celsius of the line. Okay, take a screenshot if you please. Next, question number 4. As you can see here, what do we have? Okay, there is no multiple choice question. There was in the old syllabus multiple choice question, but according to the new syllabus, they don't ask multiple choice question. Maybe a part of the question they give you several choices and choose as a multiple choice question, but no. Okay, question number 4, what do we have? When an object is in contact with a horizontal surface, okay, there will be maximum friction force F between the object and the surface before sliding. F is given by the equation F equal mu times N, and we know that mu is constant and N is the normal contact force between the object and the surface. You are going to study this equation in mechanics M1, inshallah, or maybe you studied. A student investigates the relationship, okay, of a rubber block, okay, on a concrete surface, okay. She sets the apparatus as shown in the diagram. She brings a slab of concrete, okay, and she put the rubber of 250 grams of block rubber, and she puts mass on it, and they tie it with a string that pass through a small smooth pulley, and this pulley has several slotted masses. We can change the mass on the pulley to know how much is the minimum force that we need. Okay, the maximum, the minimum force that we need, which is the maximum force of friction until it starts to move, as they said, okay, before slide or before it moves. A, describe how the student can determine F of the situation shown. What I need to do? 2 marks. I will put the slotted mass, okay, on the pulley and keep adding small masses on it, okay, until what? Until it start to to move. Okay, when it start to move, I need to to find how much is is the friction force. Now, also I can change the mass, okay, above the rubber block, so can find what is the value of the force. Okay, so I can measure the weight of the masses, or I can calculate it directly from the friction, okay, which is equal mass times gravity acceleration to know how much is the normal reaction. Okay, since vertically there is no resultant force, but horizontally it maybe start to move at certain point. So Hamza Rahal also give an answer. MashaAllah alayka Hamza. Keep adding masses at the pulley, at the end of the pulley, at the slotted masses, okay, until it start to move. Determine the friction to determine the friction force. Okay, so thank you, Hamza. Keep adding small masses at the slotted masses, okay, until it start to slide. Then calculate the force, which is F equal M multiplied by G. M is the total slotted masses. Okay, take a screenshot. Part B. A student varies the mass M placed on the top of the rubber block and determine the corresponding value of F. Her results are shown in the table. The mass 0, 200, 400, 600, 800. The normal contact, she found it like this by multiplying, okay, the values, okay, with the gravity acceleration, because we changed the mass here, but the rubber is still, okay, tamam. And this is the normal reaction force. And yes, using the W equal mg, or the normal reaction equal, and both masses multiplied by gravity acceleration, and the force by doing the experiment by the slotted masses, okay? Then what they ask here, okay, explain how the values of n are calculated. What we do, we add the mass m with the mass of the rubber, mass of the rubber, 250 grams. Then what, ya shabab? Yes, exactly. We converted from gram to kilogram, divide by 1000, then multiply it by what? Multiply it by gravity acceleration, G, gravity acceleration. Okay, sir, no problem, no problem. Okay, try to send another link for her, because I can't now. Thank you. Next, double I. Plot a graph of f on the y-axis against n on the x-axis using what? The grid below. Now, as you know, since the IGCSE, okay, now we have to draw the best fit line, okay, and it's not necessarily to start from 0 every time we have, okay, values. But here, since we have a relationship, we have to start تقريبا, okay, almost from 0. Maybe we are not going to start from 0 because there is other forces, not only friction force, maybe in the pulley, maybe other side. So we have to determine it, and maybe they are going to ask about the gradient, which is the value between n and f, okay, to find the coefficient of friction, the constant value. So as you can see, I'm going to start from what here, from 0 to 0, okay, and the maximum value of the force on the y-axis, okay, which is in Newton, and the normal reaction also, which is in Newton, okay, the maximum value of the force, it's supposed to be above 5.8 to make my own scale. So if I put it here, 1, 2, okay, so I will write 1, 2, 3, 4, 5, 6. That is good scale. So I'm going to write it in this way. So it will be 1.0, 2.0, etc., 3.0. Don't forget to draw this with pencil to try to be more accurate. Then you can redraw it with pen. Okay. Sir, how do we use the scale of the graph? Okay, struggling in this. No, it's not struggling. Okay, because the force here, it's the maximum value of the force, it's 5.8. So if it's above it a little bit and you finish more than two-thirds of the graph, okay, or the scale, this is a suitable scale. Okay. The same thing on the what? On the load here. Okay. So for example, in the normal reaction that starts from 2.45 and finish at what? 10.3, I can do this, okay, and let's say that's here. If I start 1, 2, 3, 4, 5, 6, 7, so it's not enough. So that means I will make it what? Bigger scale. So I'll make it 2, okay, 4, 6, okay, and here 8, 10, okay. Now in this situation, I can be what? More accurate by plotting what? My graph, because I cover more than two-thirds of what? More than two-thirds of the scale, okay. Then I'll put the graphs. And as you know that the plotting that's supposed to be to the nearest what? To the nearest value. For example, the first value was 1.4, here 1.4 with 2.25. Okay, so it will be somewhere here. Okay. Now the plotting, as you know, it can be a dot with a small circle. It can be with what? With a cross. It depends on you. So after we plot the graph, okay, after we plot the graph, and the graph, I will not go to plot it now. You can plot it because you know it. Okay, it will be something like this. Okay, this is the first point. Okay, and the second point, it will be 2.5 with 4.41, which is somewhere here. The third point, it will be 4 with 6.38. Okay, like this. Then 4.6 with 8.34, somewhere here. And the last one, تقريبا something, okay, not exact values, okay, and 5.8 with what? With 10.3, somewhere here. Then what? I'll draw the best fit line. The best fit line, okay, it's not necessary to pass through all the points. It's supposed to be as close as possible through these points, okay, and the most number of points can be clear on it. So I can draw the best fit line something like this by ruler. Okay, it's not necessary to be from the first to the last dot, the first plotted point to the last plotted points. Okay, it's not necessary. After I draw this straight line, okay, maybe I can draw it from the origin. It depends on your decision if it starts from origin or not. If it starts from the origin, that means, okay, there is no other factors that affect this experiment. Okay, there's no y-intercept, as you know. Okay, and if it doesn't, that means there is y-intercept, and maybe they ask about it. So it depends on you first. So for example, if the points, for example, okay, if the points was like this, I can't start from what? From zero. I'll start from somewhere like this. Okay, so it depends on you how you are seeing it. Okay, good. Any question? This is 5 marks question. Okay, then determine the value of mu. And as you told me, okay, and as you here I can see on the chat, now if the friction force equal mu r, so mu n, oh sorry, mu n, so that means mu equal friction divided by normal, which is obvious the gradient. So what I'm going to find, I'm going to take 2 points, which is clear. Okay, now since my drawing is not by ruler, I will not be as accurate as you are when you are drawing it. But you have to know and you have to show them that, for example, a clear point like this that has a clear intersection, like this one. Okay, and another point from the end region here, for example. Okay, like this one. And you have to show them that you draw a big right angle triangle, okay, like this. On the graph, you have to draw this, okay, and then what? Indicate how much is what is the gradient, and for sure, there's range of the accepted answer, okay. If we look to the mark scheme, we can see that there is range of the accepted answer. Hold on, okay. Question number 4. Yes, look here. The gradient has range between 0.54 to 0.59. Okay. Now, who can tell me what's the unit of the best fit of the gradient here? What's the unit? Yes, it doesn't have unit. Why? Bravo. Why it doesn't have unit? Because Newton over Newton, they cancel out each other. It's unitless. It's a ratio. So if I take this coordination, okay, of this point, which is 6, minus the point of this coordination, which is 0.7, divide by the coordination of this point, which is 11, minus the coordination of this point, which is 1. Okay, that means my answer, it will be 0.53. Okay, I'm not accurate. I didn't draw it as accurate as possible, so that's why I'm out of the range. So maybe I'll lose a mark. But in your drawing, you'll be more accurate than mine because I'm not drawing on a paper. I'm drawing on a screen actually, okay, on a pad. Good. Any question? Is it clear? Okay. Next, what do we have here? Part D. A tire manufacturer carries, okay, out similar tests on a sample of rubber, okay, used by the tire. Suggest why test, okay, these tests are what necessary. Why do we need this test? In reality, in cars, why? One of the answers, the rubber can handle high friction force. Okay, why do we need this test? Durability to check, okay, what do you mean by this? I'm talking about cars, accidents, traffic, high speed. So why is this necessarily these tests? Because whenever the friction is higher, okay, that means I will what? I will use this braking force to reduce my speed, right? Look here, the question asks about suggest. So suggest, that means things outside the box, okay? Think about the idea that about the question itself, okay? So if we look to the mark scheme here, they give you some certain suggestion, like look here. To test tires would provide enough friction force, okay? Or to test tires provide enough what? Grip. Or to test that rubber, okay, on wet or ice or cold or loose surfaces area, okay, surface material, how much the friction it will provide. Because sometimes the concrete, it will be below sun during the night, so maybe the temperature change, maybe there is rain, okay, maybe there is ice, we don't know, so we have to control this, okay, so that the tires, okay, can stop the car safe distance, okay, or safe time. So this prevents what? From beginning a slide or what? Okay, to prevent sliding. Yes, thank you. To prevent. No, it's not durability. It's not an accident. It's a correct answer. Okay, you have to be more specified when you're suggest. And that's it, Shabab. Like this, we finish, okay, the whole exam, okay, with explanation in 1 hour 5 minutes, okay, and you know that it's 1 hour 20 minutes. If you have any question, you can stay online. If you don't have a question, you can leave. Have a nice night.